welcome to area and circumference of circles. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so just to start with, it is very important that you understand the meanings of two very important words when it comes to circles, and that is radius and diameter. Now the radius, as you can see here, starts at the centre of the circle and works its way out to the edge of the circle. The diameter goes all the way through the centre of the circle, cutting it in half exactly from one side to the other. Now you will notice that there is a relationship there between them, and that is that the diameter is actually just two lots of the radius. So anytime you know the radius, you can calculate the diameter by doubling it. If you know the diameter, you can calculate the radius by halving it. Now, this video is looking at finding the area and circumference of circles, so we then just need to think about what those two words mean. Well, the circumference is what in other shapes would be known as the perimeter. It is the distance around the outside of the shape. And so the circumference is the distance around the outside of a circle. The area, well, that is all of the space within the circle's circumference. So everything within the circle, it would cover as the area. Okay, so what we're going to look at next is a little method of actually remembering the rules for finding circumference and area of a circle. And I'm going to do that through a little song. So I'm going to humiliate myself a little bit on video, but if it helps you remember, then all the better. So we're going to have a little bit of circle-okie, karaoke all about circles. And so we begin with the words which are on the screen, and it goes something like this. Circumference of a circle is pi times diameter, pi times diameter, pi times diameter. Circumference of a circle is pi times diameter, area is pi r squared. You can do a little dance at this point if you want, all about circles. And then we can come back in later on with circumference of a circle is pi times diameter, pi times diameter, pi times diameter. Circumference of a circle is pi times diameter, and area is pi r squared. Now, if you really want to get that stuck there, committed to memory, you can have a sing of that yourself over and over again. It really does work. I've seen many students in the past sitting in exam halls nodding their head along, and I can tell straight away that they must be on the circles question because they're singing that song, and it's helped them to get the answers. So don't be worried about singing that song yourself. It will help you remember the words and remember the formulas. And that's the important thing, because the words are important. The circumference of a circle is pi times diameter, but what you are going to use in an exam is a formula. You're going to say that the circumference equals pi d, pi times diameter. Now, that also means that it is 2 times pi times r being the radius, because remember, the diameter is 2 lots of the radius. The area is pi r squared, and so what that means is pi r squared, it's the radius squared, and what I should just point out in each of these cases, pi d, now that means pi times diameter. 2 pi r, that means 2 times pi times radius. And in the case of area, pi r squared, well, that means pi times radius squared. And so the radius needs to be squared first and then multiplied by pi. I should also mention what this little pi is. This is the symbol pi. It is read as pi, because that's how it's spelled. It's a Greek letter. It's a Greek letter for a number which is roughly 3.14. It does go on forever and ever and ever and ever, infinitely many decimal places, but 3.14 is roughly what you need to remember about pi. So what we have is 3 different circles here, and what we're going to do is we're going to try and find the area and circumference of each one. And so straight away, the first thing I want you to do whenever you see a question about circles is just write down 2 things. I want the radius and I want the diameter. because it's going to be important. You will probably only be given one of those pieces of information in a question. You need to be able to work out the other one. So in this case, we've been given the length from the centre to the outside. That is the radius. So we've got that the radius is 3. Now the link between the radius and the diameter, well, the diameter is 2 lots of the radius, and so the diameter would be 6. Now all I'm going to do is I'm going to write down circumference, and just to remind myself of what that formula is, circumference of a circle is pi times diameter, and so in this case it's pi times 6. Now if you didn't have a calculator, 6 pi would be a perfectly acceptable answer here, and actually it is the perfect answer. It is the most accurate you can possibly get. But if you do have a calculator, then all you need to do is grab that and type in dot 6 pi, or pi times 6. So just grab the calculator, and we've been asked to do pi, which is shift at the times 10 to the x button, times 6. And your calculator tells you it is 6 pi, but that is because that's giving you it in surd form. We want the decimal. Let's press the SD button, and we get 18.849555592. We'll round that. We'll go to 2 decimal places in this case. So the circumference in this case would be 18.85 centimetres. And importantly, it is centimetres. It is just a length around the outside of the shape. The area, well, for area is pi r squared. So pi r squared. In this case, the radius is 3, and so this is pi times 3 squared. Now again, you could get this without a calculator. 3 squared is 9, so 9 pi, and that would be a perfectly good answer. But if we had a calculator and we were asked to give it to 2 decimal places, well, we would type into our calculator shift and times 10 to the x to give us pi times 3 squared. And we do that, we get 9 pi. We press it again, 28.27. So 28.27 centimetres squared for the area. Remember, area is always in a unit square. For the 8 centimetre circle, well, again, I'm going to write down radius and circumference, radius and diameter straight away, and that is so that I can just keep track of what I've actually been told. Now in this case, the line that we've been given is the one that goes all the way across. That means it is the diameter, so the diameter is 8. The radius, well, that is only half of that, and therefore the radius is 4. The circumference is pi times diameter, and so circumference in this case is going to be pi times 8, which is quite obviously 8 pi, but again, if we jump to our calculator, pi times 8 is 8 pi, or 25.13. So in this case, 25.13 centimetres. The area, well, that is pi r squared, and so we've got pi times 4 squared. Pop that into our calculator. Pi times 4 squared equals 16 pi, or 50.27 centimetres squared. Finally, we have a circle here with a length marked on of 2 meters. Now again, I want to just write down radius. I want to write down diameter. And in this case, we've been given the length from the center to the outside, so that is a radius. It's a radius of 2. The diameter would be double that length, being 4. And so then the circumference will be pi times diameter, and therefore it's pi times 4. And if we type that into our calculator, pi times 4, that would be 12.57. 12.57 0.57. Now with this one, I just want you to be careful of the units you were given to begin with. In this case it was metres, and therefore the circumference is also metres. The area, well, that is pi r squared, and so that's pi times 2 squared. If we type that into our calculator, shift pi times 2 squared, well, that equals 4 pi, it equals 12.57. And in this case, metres squared. Now you may notice we have exactly the same answer for both. Now that is something which is only ever going to happen in this situation. A radius of 2 and a diameter of 4. And the reason for that, if we do pi times diameter, well, the diameter is double the radius, and 2 squared is the same value. So 2 times 2 and 2 squared are the same thing, and therefore we actually get exactly the same result for both. Okay, so next we're going to look at how to find a radius of a circle if we've been given either the area or the circumference. And basically it always comes down to the formula for whichever one we've been given. So in the first question we've been told what the area is, and so the area is pi times radius squared. Now in this case we've been told what the area is. We've been told that area is 26. Now the pi, that's always there, and the r squared will also be there too. What we're basically trying to do here is to solve this equation to get r all on its own. And so the first thing we're going to do here, we're going to have to divide by pi. So 26 divided by pi equals r squared. Now if I need to get r all on its own, what do I need to do? Well, I actually need to square root both sides. And so I'm going to do exactly that. I'm going to square root 26 over pi and get r all on its own. Now you'll notice here that I haven't typed any of this into the calculator yet, and that's because if I do, I'm going to lose a little bit of accuracy on each little stage. So I want to leave that until the very end so that I try to get as accurate a picture of the answer as possible. And so I'm just going to grab my calculator, I'm going to use my square root button and the fraction 26 over pi, 26 over pi, and let's get an answer. Well, that equals 2.876813696. Now in this case, let's just give it a 1 decimal place. So let's say in this case our radius is 2.9. So the radius is 2.9 centimeters. In our second question, we've been given the circumference. So we're going to need to use that circumference equals pi times diameter. Now, pi times diameter, well, circumference here is 21. That equals pi times diameter. So in this case, if I want to find the diameter, well, I'm going to have to divide by pi again. So 21 divided by pi will give me the diameter. And so if I type that into my calculator, 21 over pi, well, that is 6.68407 and so on. So the diameter is 6.68. But it wasn't the diameter we were asked for, it was the radius. So now that we know the diameter, to get the radius, well, I'm going to have to divide that answer by 2. So divide 2 and we get 3.3. 3.3 centimetres. And lastly, the area of this circle is 3.14 metres squared. So what is the radius? Well, again, area equals pi times radius squared. And we've been told that the area is 3.14, and that is pi times radius squared. And so, in order to get the radius on its own, I would have to divide by pi, and then I would have to take the square root. So the square root of 3.14 over pi, that is going to be r. And so let's grab our calculator. Square root of 3.14 all over pi, and that equals 0.99974648892. So to one decimal place, it is actually 1. And so the radius of this circle is 1 metre. And so we come to our final set of examples, and this time I'm going to ask for the area and the perimeter of each of these shapes. Now you'll notice that I've changed my phrasing from circumference to perimeter, and that is because the word circumference only exists in circles. These are not circles. They're to do with circles, but they are not circles, and therefore the perimeter in this case is the name for the distance around the outside. Now I'm going to begin with what is a semicircle. We've got half of a circle, and we're trying to find out the area and the circumference, and the perimeter of this shape. And so the same thing as we've done before, we're going to write down our radius and we're going to write down our diameter. Now at the moment we don't really know what is what, but if this was a full circle, well, what would that 4 centimetre line represent? It would be the line going from one side to the other, and so that is our diameter. If the diameter is 4, then the radius is 2. Now, if I wanted to find the circumference of the full circle, so going all the way around, well, I would do pi times diameter. But in this case, I don't actually want a full circle. I only want half of it. I only want the piece around the outside here. And so I'm going to do pi times diameter, but then I'm going to divide it by 2. So I'm going to get the full circumference first. So that is 4 times pi, and that is 12.566. But I want to divide that by 2 in order to get just the red curve. So divide by 2, and so that is 6.283. But that would not be the perimeter. The perimeter needs the curve around the outside and this straight edge here. So we would also then need to add the 4 centimetres, and so the perimeter here would be 10.283 centimetres. So that would be the perimeter. Now the area, we're going to have to look a little bit more carefully. So the area of a full circle is pi r squared, but this is not a full circle. How much of a circle is it? Well, it is half, and therefore the area of this shape is going to be pi r squared over 2. And so here we have pi times 2 squared all over 2, and if we type that into our calculator, that is pi times 2 squared all over 2, comes out as 2 pi, or 6.28 centimetres squared. The next shape, we can obviously see it's something to do with a circle, but in this case, how much? Well, if I were to make it into a full circle, we can see here that actually what we've got is a quarter of that circle. And so, once again, what does this length here that we've actually got marked mean? Well, that would be the radius of the full circle. So the radius is 3 and the diameter is 6. So, how would I work out the circumference or the perimeter? Well, in this case, I need to know this curved edge here. And so that is going to be a quarter of the full circumference. So circumference was pi times diameter, but for this one I'm going to divide it by 4, and so pi times diameter divided by 4, so shift pi times 6, and then that's divided by 4. That is 4.712. And we then need to think about these straight edges. Now the straight edges here, well, we've got a 3 centimetre side here. This side must also be 3 centimetres because they are both radius of the circle. And so I'm going to have to add 3 and add 3. And so I'm going to have 10.7 centimetres as my perimeter. The area, once again, we want to go to our formula for area of a circle. The formula for the area of a circle is pi times radius squared. But this being not a full circle, but instead a quarter of it, means we're just going to divide it all by 4. And so in this case, we're going to have pi times 3 squared all over 4. And that is 9 over 4 pi, which is 7.06858, or if we go into one decimal place, 7.1 centimetres squared. The last shape is a combination of different shapes. What we've got here, if we think about it, breaking it down, well, here we have a rectangle, and then here we have a semicircle. And so we're going to need to treat both of those as 2 separate pieces to start with. So if I were, first of all, just thinking about the circular element here, well, the piece of information that we actually know about this is the line along here. That is the diameter. So I've got radius, diameter. I know that the diameter must be the same as this 4 centimetres here. So the diameter must be 4 centimetres, meaning the radius is 2. And we want to find the perimeter of the shape. And so the first thing I'm going to work out is this curved arc at the end of the shape. So the circumference will be pi times the diameter, which is 4. But this is only a semicircle, so I'm going to half all of that just for the curved section I've marked. Shift pi times 4 divided by 2 is 2 pi, which is 6.283. And then, if I'm finding the perimeter, well, I need to think about what else makes the perimeter. I have this length here, which is 6, so I need to add on 6. I've got this length here, I'll need to add on 4, and this length here, I'll need to add on another 6. And therefore, I'm adding another 16 in total, giving me 22.3 centimetres as my perimeter. The area, well, in this case, again, we're going to have to take it as 2 separate pieces. I'm going to find first the area of the semicircle. So the area of the semicircle will be pi times radius squared, but halved because it is only a semicircle. And so that is pi times 2 squared divided by 2. And so we get 6.283. And so that is the area of the semicircle. Then we need the area of the rectangle. And the rectangle, well, that would be 6 times 4. In this case, 24 centimetres. What are you going to do with those 2 pieces? Well, you would need to add them together. So 6.283 plus the 24, well, that's going to be 30.3 centimetres squared. And so we'll end with the exam question. It came from the Edexcel paper in November 2018. It was Foundation and Higher, paper 1. So just to start there, Foundation and Higher, it's a crossover question. It's a grade 4 to 5 topic. But also paper 1 means it's non-calculator. Now that means that we cannot use a calculator in this. We're going to have to deal exactly with exact values of pi. So it states that the diagram shows a square ABCD with sides of length 20 centimetres. It also shows a semicircle and an arc of a circle. AB is the diameter of a semicircle, AC is an arc of a circle with centre B. Show that the area of shaded region over the area of the square equals pi over 8. Now this is a very tough question and it's got quite a lot of work to it, but if we take it in very small steps we should be able to build up marks as we go along. Now the question is all about area, and it's got the area of the shaded region, the piece that's in grey, and area of the square. So can we do anything quite straightforward to begin with? Well, the first thing we could think about is how do we find the area of the square? Well, because it's a square, all of the sides are the same length, so that is 20 by 20. So all I'm going to do first is just write down what the area of the square is. The area of the square is 20 times 20, which is 400 centimetres squared. Now that on its own would be worth a mark. But then all I want to think about is, can I work out the areas of these pieces of circle? Well, let's go with the unshaded section. So this semicircle. In this semicircle, what do we know? Well, we know that this length along the bottom is 20. Now that is the diameter. So diameter in this case is 20. So what is the radius? Well, the radius would have to be 10. Now we're dealing with area here, and so area is pi r squared. But in this case, this is only half of a circle, and so I'm going to divide it by 2. And so that's pi times the radius squared, so 10 squared all over 2. What is 10 squared? Well, 10 squared is 100. So 100 over 2 is 50, and so that is 50 pi. So this piece here has an area of 50 pi. If I wanted to now deal with the grey section, now I'm going to include the piece that we've just worked out. I'm going to find a quarter circle in this case. Now, the 20 in this one, that is only the radius of the circle. So the radius of that one is 20 and the diameter would therefore be 40. But again, we're only dealing with area. So the area is pi r squared. But this is only quarter of a circle, so I need to divide it by 4. And so that is going to be pi times 20 squared all over 4. Now what is 20 squared? Well, 20 squared is 20 times 20, which is 400. 400 divided by 4, well that is 100. And therefore, the area of the full piece of the quarter circle is 100 pi. But if we now go back to the diagram as it is, then we've just worked out the entire quarter circle, but we need to remove the piece that is not shaded in. And so we need the area of the full quarter, which is 100 pi, and we need to subtract the area of the semicircle. So we need to take away 50 pi. And 100 pi, take away 50 pi. Well, this is just like with algebra. 100 of something, take away 50 of something, is 50 of that thing. It's 50 pi. And so, what we now know is that the shaded area is 50 pi. Now going back to what the question actually asked. It was the area of the shaded region over the area of the square. Now the area of the shaded region, well that was 50 pi. The area of the square, well that was 400. How would I simplify that expression? Well, I would divide both by 10, say, to start with. So 5 pi over 40. And then, is there anything that goes into 5 and 40? Well, 5 goes into both. So that would give me pi on the top. 40 divided by 5 would be 8. And so what we're saying is the area of the shaded region over the area of the square is pi over 8. And that is exactly what it was meant to be. pi over 8. We've completed the question.